Dear students, in the last session we have designed the main robot like this. This was designed in the last class. So this robot, in this particular case, I have given velocity to the left motor. So that's why it is revolving around that motor. So this robot, which we have designed in the last session, we are going to use the same robot for our next practical. So our next practical is the obstacle detector and a robot which can detect the obstacle. So this is the demo uh, simulation which I am going to show. This will be the end result of the but this today's session. So when we play in this particular case, this robot, here you are able to see this robot is able to hit these obstacles and it is changing the path accordingly. So let's start with the designing of such robot. In this case, you are able to see the view of this camera as well, which is connected to this robot. All this we are going to do in this particular session. So for that, we need this file in which we have designed our robot. So this file is already shared in VB. So from there, you can download this particular experiment 3.3 starting file, and all of you please work on this file only, because if any mistake you have done in your file, then the robot will not work. In the similar way, I have shared three more files of the code which you are going to use in this particular practical. So first we are going to we are going to have these obstacles in our window. So for that, we can add those obstacles from in here also, in this scene also, but we always prefer to bring new objects in a new window, so that it will be easy to differentiate between the different objects. So open new scene. Here in new scene, we are going to create those cylinder obstacles. So for that, we are going to add new object. You know the procedure for adding new object. Go right click, add, go to primitive shapes. Now select cylinder. So cylinder have two dimensions, one in X direction, one in Z. We can take any dimension of our choice. Here I am going to take 0.1 X value and 0.2 Z value. Always click any other box so that these values get saved. Okay. So here we are having the cylinder in our window. Next is to change the properties of this cylinder. So this is the property symbol. This small square box is there. We have to click this blue box, double click. First go to common. Here we need to select common and make this cylinder collidable, measurable and detectable. Now after this, we have to change the dynamic property of this particular object. Again, same procedure, just click this symbol, square symbol, go to show dynamic property, and you have to make sure that this body is dynamic option, this one. This body is dynamic option should be unchecked. This should be unchecked. Otherwise, your cylinder will fall down when robot will hit it. Otherwise, what we are doing, we are making this cylinder as static object, so that it should not fall whenever any other object hits this particular cylinder. So this is very important to do. So here we have to make this body unchecked, body is dynamic and cross. Now, next move forward. So we have changed both the properties. What we are going to do, we are going to copy the same cylinder. Must remember, you have to do two changes. One in dynamic property, another in common, collidable, measurable, and detectable. After that, Control C means select the cylinder and press Control key and C. Copy the object and multiple times Control V. 10 to 15 times you can do this task. Control V. So all the cylinders are on the same position. So next task is to change the position. We are going to arrange it in that circle way like this our main front. So now first select any cylinder, click position tab, then drag this in the scene window. Again, select any cylinder. Just you have to click the cylinder. Once you have uh, selected the position tab, then you don't need to select it again. Like this way, you are going to arrange it in circular manner. So all the cylinders which you have kept in the particular scene, adjust the position just by simply dragging these cylinders. All the cylinders you have to drag in this manner. You have to make sure that your main robot file should be correct. Whatever steps I have discussed earlier, you have to take care of. Now all the obstacle scene is ready. I am going to again press Control key and select all cylinders. Make sure your Control key should be pressed. Otherwise, these all cylinders, multiple objects, you are not able to select these objects. Control C. Now come to your main window where you have just created your main robot. Experiment 3.3 robot is there. Control V. So now you are able to see all the cylinders in front of this in front of this robot. Now here in one motor the already velocity has been given. So we need to give velocity to another motor. We know the procedure how to give velocity. For that we need to click this symbol of left motor and go to show dynamic and give the velocity. Earlier I have taken 100 velocity, so I am taking 100. If you take 200 velocity, then you have to take the same velocity. Cross this and now we can check that whether it is working or not. The robot is moving in the forward direction, but the thing is it is not able to find the obstacle. So next step is I am just bringing this obstacle in front of this robot. Let's see what it is going to do. So right now this robot is just crossing the cylinder and stuck there because we have not given any code. If this robot find any obstacle, it should change the direction. So for that we are going to give some codes. Before that, here we are going to uh, connect one monitor screen like this and one camera to this particular robot. This camera will work like as our eyes do the work of us. So camera is required so that this robot can see the environment around it. So for adding the camera, what you need, just right click, go to add, and here one option is there. Vision sensor option is there. Vision sensor option is there, and we have to select perspective type option. Now, after this sensor, when we added the sensor, we have to connect the sensor with the sensing node. Again, make sure that the sensor should be connected with the sensing node. We know the procedure how to connect to object. Here we are going to make our sensing node as the parent. So first, select this sensor, then press Control key, then sensor node, right click, go to edit option, make last selected object as parent. What we are doing? We are making sensing nose as the parent and this vision sensor as the child. Next step is to rename this vision sensor. So for renaming, just double click the vision sensor and remove the vision underscore, which is a by default name. We have to change this because the name which we are using in the scripts, these names should be same. Otherwise, code will not run. So enter, make sure that you have to press enter while your cursor is inside the box. Otherwise, the object will not get in. Next is you do this task only on sensor. Don't get confused with the sensing mode. Be careful, your sensor should be connected, not selected, not the sensing mode. Now next step is to change the orientation. You are able to see this camera view is in upward direction. We have to get this view in the forward direction. So for this, go to position, select the sensor, go to position. Position sub-tab should be selected. Make sure position sub-tab should be selected. Here by default word option is there. You have to select parent frame and then give X, Y, Z. Parent frame selected, then give X, Y, Z all three coordinates as 0 and select any other square box. Cross this pop-up window. Repeat these steps for orientations as well. Orientation button, you already know this is object item rotate button, which is also known as orientation button. Click this button. Select the orientation sub-tab. Be careful, this sub-tab should be selected. Select the parent frame. Again, parent frame should be selected. Alpha value should be 0. Gamma value should be 0. And beta should be 0. Cross this pop-up window. Now here you are able to see that the camera view is in front direction, forward direction. But it will see the environment, but we are not able to see that what observation it is going to take. So for this, we are going to add one monitor in this scene. So to add one monitor, what we need, we are going to do again right click, add, add floating view, floating view. Now this monitor has been added, but this is not connected with the selected sensor. We can have multiple monitor in the same scene, multiple sensors in the same scene. So you have to give connection to each monitor with the respective sensor. The procedure is for the same. Select the sensor. Make sure your sensor should be selected. Right click this floating view, which is empty right now. Select view and select associated view with selected with the sensor. Means it is going to connect the monitor with this particular sensor only. When we are going to run our simulator, now here you can see that this is able to observe this obstacle. Whatever it is able to see, we are able to see in this monitor. The picture is blurred, so we can change the property. How we can, and whenever you do any change in property or any other change, always make sure your this stop button should be selected. While you are running the simulation, that time you cannot make any change. So for changing the sensor property, we should double click this sensor symbol, go to this particular pop-up window. Resolution XY is there. So here just increase the resolution. I am increasing it with 256 value. 256. Now again, always make sure that you should click any other box after filling your required value. Cross. Now we can see this is showing much better view, much clear view. Earlier the picture was blurred. So now what we did, we have connected the vision sensor, we have bring our obstacles in the window, and what we did, just we have added one monitor as well. In the main window, you are able to see one graph is also there. So this graph is plotting the value. So to have this graph in the scene, the procedure is The procedure is just again right click, add, and graph option is there. Now, when you add graph, please make sure to rename this. Again, this is very important step to remember. You have to rename graph as well because here G is capital and in our code G is in small. So this is a case sensitive particular case sensitive is there. So we have to take care of graph. We can take any name, but you have to use the same name in the script as well. So that's why we are doing this change. So select this graph again and connect this graph to the bubble graph. How to connect again? Control, select the graph, control key, bubble draw, right click, add it, make last as parent object. Now, whenever you are doing the work, please check the hierarchy always. In this way, this should appear. In this way, this should appear. Always make sure whenever you do any task, rename your file so that and press Control S during the session so that if because of any reason this is going to stop, your work will be saved. So you know the procedure, go to file, just save this scene or save as you can do and copy a scene and save the same scene with your UID or name. Make sure renaming you do the renaming in proper way. Save this file with your UID or name. So whatever name you save that will appear as a file name here. So now what we were doing, we were connecting this graph with the bubble block by selecting both the objects and add it and make last as field. Now next is to shift the position. Right now you are able to see this graph on the floor. So we are going to shift this graph little bit above the floor. So graph, select the graph, go to position subtab should be selected and I am giving here Z as 0.005. 0.005 so that this graph should shift in Z direction, Z coordinate. Now, again, if we run this particular code, here we are not able to see the graph as well, and the robot is not going to sense the obstacle. So now last step is to make this robot as a obstacle detector, means it can sense the obstacle and it can change the direction when any obstacle is there. And graph is also not there because we have to write the script for the graph as well. So last step is to add the script to bubble raw and sensor. So first in bubble raw, how to add the script? The procedure will remain same. Select the bubble raw, right click, add and select associated child script option is there. You have to select associated child script, non-threaded and Python. This should be the path. This should be the path. Now, after adding this, you are able to see one small file option just near to this bubble rock. Similarly, repeat the step for the sensor. Select the sensor, select the sensor, right click, add sensor, not the sensing node, sensor. Associated child script, not threaded, and Python. Now, here we have to add the scripts. So I have already provided the scripts. So here we are having three scripts with us. One is for bubble rock file is there. This word file is with bubble rock. Another is for vision sensor and for graph. First of all, open bubble wrap script. Here, script has been written in the way whatever task we want to get it performed. So, Control A, Control C, bubble wrap. I am going to get the script of bubble wrap. Just double click this script C, bubble. Just double click this script symbol and do the control. Select all these script material and control V. Just delete the previous one and control V and upload this. Here this restart script is there. Here we are going to change the script. Just click this option. Cross. Repeat the step for the sensor as well. Double click the sensor script. Control A. Delete. And open our Word file where script of vision sensor is already given. Control A. Control C. Open the copy sim. Paste. Control V. And upload and cross this pop-up window. Similarly, here in graph, already the associated script file is there. You have to just double click. You don't need to add it again. Just take one line code of the graph as per our requirement. As per our requirement, just paste it and now what you need to do, just open the file, take one line of code, Control C, and replace the code with that particular code. Now upload this again, cross. Now your all the task has been over. Just check by playing this. Here you are able to see graph is also going to plot. Here you are able to see this detector is able to detect the obstacle. One control is there because you can control the velocity of the bubble robot like this. So the robot is working fine as we have designed. This is working in the same manner. One more option is there. So it has found one path there. That's why again it has changed the direction. Now you can observe it very carefully. Here one option is there, multiple screen window. So this name, the name of this option is page selector. Just adjacent to I, this option is there. I'm going to tell you where it is. This particular option is there. This particular option, where is my cursor? This is the option where you can see uh, when you click this page selector, then you are able to observe that this can open the multiple screen. Here you are able to see different views, top view, side view, left view, right view, all the view in page 7 as well. So you have to take the records of these screens as well, and you can play and you can go to the previous window just again by selecting this option of page selector means multiple screen option. You can play your robot and again see the view from different angles. So in this way, you can complete your task. So here you have to take care of the names because if any name will be changed from the script, then this will not work. This is the next practical. So in the last practical, we are going to design one path follower. For that as well, we are going to take our main robot again, which we have designed in the practical 3.2. Then by taking that robot, we are going to complete our next practical of line follower in the next video. Thank you so much.